Good morning, Kasturians. So today we have to study thin lens formula from chapter number 9, which is ray optics. First of all, for this formula, or you can say for to derive thin lens formula, as you can see the lens here, there are some assumptions to this lens. For this lens, so let us see one by one these assumptions. The first assumption is that this lens that is used here to find out this formula, this lens should be thin. Okay, the lens that we are using, it should be thin. Second thing is the aperture of the lens, it should be very small. Okay, if we are see, if we are having thin lens, let us consider this is a type of lens. So the aperture, if we are talking about the aperture of the lens, it will obviously be small. Okay, so for the thin lens we need the small aperture. Okay, now what we have to consider next is that the object the object is very small. Okay, and this is the object should be very small, and this object should be placed on the principal axis. Okay, we have to consider here, for this we have to consider basically the point sized object. Okay, now let us see this figure. What is this saying? See, this is a lens we are having, this is a convex lens. Okay, now we are having an object which is placed at this point B. This point B is between the focus and the center of curvature. Okay, here we are having this point, and let us consider this object is having the height A and B. Now from here the first ray goes straight to the lens, and this after the refraction, this row travels from the, or you can say this row emerges out from the focus. See, this row is going straight, that means the ray going parallel to the lens, it goes through the focus. Okay, we already know this. Now there is another ray which goes straight from here to center of curvature of the lens, or you can say this, from this point O, and it goes straight. And these the two rays that goes, the first ray is this AM and the OA. They both the rays after the refraction, they meet at point A. Okay, and this point A, see, initially the object was placed between focus and center of curvature. Now when the object is placed between focus and center of curvature, we get the image beyond center of curvature. Okay, so this is what we have got the image beyond center of curvature. And you can say if the height of the object was A and B, the image is A dash and B dash. Okay, and which kind of image we have got? We have got this image. As you can see, this image is on the right side of the lens, or you can say in the direction of the ray. This is real image. And what else? This ray, see, the height of the object, initially it was upwards, the object was like this, and now see, the image of the object that we have got is downward. This is arrow is pointing downward. So what is this? Okay, now let us see from the triangle A dash. This is triangle A dash, B dash and O. Okay, first we have to consider this triangle A dash, B dash, O, and here this side we have to consider this triangle, that is A, B and O. From this triangle, what we can see, that A dash, B dash divided by, see, these two triangles, as you can see, they are similar. Okay, and from the two similar triangles, can we say that ratio of their sides are equal? Okay, like A dash B dash upon A and B is equals to O B dash. Okay, ratio of their sides are equal, so O B dash will be equal to O B dash upon O B will be equal to A dash B dash upon A B. Okay, this is what written here. Okay, now let us take the another triangle, that is A dash, B dash and F, and on the same side let us take the other triangle, which is OM and F. Okay, from these two triangles again are similar, as you can see now. From these two triangles also, A dash B dash upon OM, it will be equals to what? The ratio of their base, that will be F B dash upon F O. Okay, and what do we see? See, this is what written here. So what we can see is, see, here we are having A dash B dash upon M O, it is equals to F B dash upon O F. Now let us see, A F B F are okay, we can understand this, but MO, see, this is MO and this is equals to AB. Can we write AB in at the place of MO? Okay, that is what written here. See, this is a dash b dash and mo if we have taken equal to ab. Now we have replaced this, so we have got a dash b dash upon ab, it is equals to f b dash upon of. Okay, the initial equation we have considered as equation 1 and this is equation 2. From both these equations we can see that on the left hand side we are having the same value. Okay, a dash b dash upon ab we are having same on left hand side. So from 1 and 2 can we say that o b dash upon bo it will be equals to f b dash upon of. Okay, so from these two equations we have written this, and this is what is this, and can we see from the figure as ob dash. What is ob dash? It is v, that is the final. See, ob dash is v, that is the distance at which image is formed. Now bo, what is bo? This is ob dash and this is bo is u, that is initial distance. Okay, initial distance means the position at which object is placed with respect to the origin. What is fb dash? Fb dash is okay, can we see from the figure fb dash is, this is fb dash. Okay, we want to find out this fb dash, this much distance. So how we can find out? Can we take this from o b dash, can we subtract o f, then we will get this distance fb dash. So from this distance is v minus f, we will be having fb dash. Okay, so that is what we have taken. Fb dash we can put as that we can put as v minus f. Okay, and what we are left with? We are left with of. Of is simple focus. Okay, so that is we have substituted all these values in this equation, and what do we get? And see, according to the sign convention, what we will take to bo we will be like this is our length, so this side of the, on the left hand side, all the objects will be considered as negative, and on the right side whatever will lie, it will be considered as positive. Okay, so according to the sign convention, this u will be negative and all the other things will be positive. Okay, if we substitute all these values in this equation, what do we get? We get some this kind of equation, that is v upon minus u, it will be equals to v minus f upon f. And after rearranging this equation, what do we get? We get the length formula, that is 1 upon f is equals to 1 upon v minus 1 upon u. Okay, so this was the length formula that we had to derive. Okay, so that's all for today. Thanks for watching the video. Okay, that's all. Thank you.